Welcome everyone to this webinar on the glare module of windPRO software. My name is Karina Brodell, and with us today we have our glare specialist Marta Mukowska. Marta belongs to the R&D department of EMD International and has been responsible for the implementation of the glare module in windPRO. If you have, and I hope you will have, questions during the webinar, please use the chat box in Teams. We'll gather the question and pass them on to Marta if it fits during the presentation or at the end, where we should have around 10 minutes. Well, let's get started. I'll hand over the screen to you, Marta.
Thank you, Karina. I'll just grab the screen shortly. Good. I hope you can see the screen. Good. Welcome to the glare webinar. I'm very happy to have you all here today with me and with us. We'll jump straight to the presentation. We start with a very simple. We start simple with a short explanation and on what is glare. And we define glare as unwanted reflections of the sun's rays caused by a reflective surface. We say that it is a continuous source of bright light encountered by a static or slow-moving receptors. It is in contrary to or different from glint, which is defined as a momentary flash of bright light witnessed by a fast-moving receptor. So we talk about a static or slow-moving receptors, in our case static, and a continuous source of bright light when we talk about glare. A short introduction or a short overview of glare regulations we have. We have here a table with 4 different countries, and as you can see, there are different aspects that are important in different countries. It is intensity, which is taken into account in all of those 4. Some of them, Germany, Switzerland, also Austria, take into account the duration. And consider these in the regulations, where we talk about in Germany, glare is not permitted if it exceeds 30 minutes per day or 30 hours per year in total, and also some regulations in Switzerland. The direction from which the glare is coming is also important, and together with a limitation on the direction from which it can come, and this we also will look a little bit more when we go into the presentation live demo in windPRO. The size of the PV plant sometimes is of concern in Switzerland and France. The location of the receptor. There is also a distance limit imposed in the regulations, where we talk about what is the distance from the PV plant to the receptor, and only if the distance is smaller than a certain amount, then we talk about having the glare assessment necessary. And glare assessment is applicable in airports, dwellings, schools, offices, depending on the country. So many places we have to perform such an analysis. More specifically, here for Austria and Germany, we have strict limits on the duration. So we say as I mentioned already, we cannot exceed 30 minutes per day and 30 hours per year for neighbors. It is a little bit different, or actually more strict for traffic, because in that case, even shorter durations can pose danger. So we say that the glare should not at all lie within the field of view of the driver or whoever is participating in the traffic. And then we have that the glare duration should be calculated from the astronomical position of the sun, and disregarding the weather. That is something we do offer. And certain assumptions for the calculations are made. So the sun needs to be regarded as a point source emitter. The reflector is a perfect mirror, so we don't talk about any scattering, or as we call it, beam spread angle. The sun is emitting light from dawn to dusk, and there is no exception for bad weather. And additional assumption that is here also included, we have that for the times of emission, only those times shall be considered during which the line of vision towards the sun and towards the PV panel differs with a minimum of 10 degrees. So if the direction from which the reflection and the sun arrays are coming is similar and it lies within these 10 degrees, in that case, we don't talk about glare being a problem since we are already having sun coming from a similar direction. And these are the specific requirements we have just as an example for Austria and Germany. Other, of course, apply in different countries. About the glare module. What is our glare module in windPRO? It is allowing the calculation of glare from solar PV objects as well as 3D objects. And currently we are allowing a calculation for point receptors. So point on the map for which you can calculate the glare influence on them. Why did we develop the module? Simply, glare assessments are becoming a requirement when building new PV plants. And we aim at offering, or we can offer now, a full chain needed for solar PV plant development. We offer energy yield calculations in windPRO, as some of you already may know with the solar PV module. We also offer photomontage with the solar PV modules included. So, and now with the glare module, we can also talk about calculating reflections from PV panels and 3D objects. So we can cover the whole, also the environmental assessment part of solar PV development. A little bit more in details what the module offers. Of course, we calculate glare. For that, we include calendar and maps. You can see exactly the time when the glare is visible, and also you can see which PV panels are causing glare, and you can see the exact placement of the receptors, PV panels, and so on. We do evaluate intensity. We evaluate intensity as the reflected irradiance from the PV panels, and we can do it for multiple types of reflectors. So we offer a built-in characteristic of different coatings of the PV panels. You can also specify a constant user-defined value for reflectivity of the PV panels. And last but not least, of course, we generate reports in which you can see the summary of the numbers of how long is the glare, what is the maximum duration of glare per day. You can also see the sun angles graph. We'll go through all of that. You can see the time per day and so on. So this is what we offer in the glare module right now. And for today's webinar, we prepared some examples. We will show you an example of glare calculation with receptors in multiple locations. We will calculate a glare from a solar PV plant. We will calculate glare from a building, which is represented with a 3D object. And we will also take you through our quick glare view tool, which is a nice tool to quickly assess the glare impact in different locations. And the picture, just so you get a little bit of an overview, is a picture taken actually from our office, and where we could see glare from a building in front of us, and our friend got disturbed in his office while working. So that's the picture we took, and also we used a video for a validation. The validation you can find on our website. We'll mention it at the end also, where exactly you can find the glare validation. Yes, I will now then jump to windPRO 3.6. For those of you who are not familiar with windPRO, I will quickly go through what we can see here, just so you can get a little bit of an overview. windPRO is a GIS-based tool, so our main component here is the map, where we can place all the different objects, and we work with this GIS layer mostly. What else we have here is we have the list of the calculations we performed. And right now we didn't perform any calculations yet, so this is empty, but we can see all the modules that are available in windPRO for the calculations. As you can see, many of them. Today we will focus on the glare module, which is in the environment group, and we will use it for our calculations. We also work with layers in windPRO. We have a result layers here that we can show on the map. We will not go through them today, but we also have object layers where we can place different objects on the map on the layers. That makes it a little bit easier to work with, and you are then able to activate and deactivate what you can see on the map. Yes, that's the short introduction. What we start with today is an almost empty project. So we will start the glare assessment from scratch. But what I already included in the project is the elevation data, and I can quickly show you our elevation data if I put it on a layer called elevation, and then I can see what is the elevation data in the project I am about to start on working. And yes, we can see that if I move the cursor on the map, I can see the Z value of the specific PV, of the specific point. And that is what is also used in the calculation. So the placement of the PV panels will depend on the elevation data, and also the placement of the receptors will depend on the elevation data that we have in our project. You can download it simply from one of the databases we have in windPRO. I will then deactivate it just so we have more clarity. I already included in one receptor to speed up the process when we build the project, but we will of course include more receptors ourselves. And we'll start with a glare assessment from a PV plant. And to do that, I will activate one of the layers of where I want to place one of the PVs. We'll work with two different PV setups, just so you can see how easy it is to do and how convenient it is then to compare the results. What we do is we place a solar PV object. We choose it from the list of objects we have here. And that's this. We can say insert solar PV object. We place it on the map. We say OK. And then we can start digitizing our area on the map. So I want to place my PV area here. So I will just start by defining the corners of the PV area and put it on the map. And then simply say that I am ready with placing the PV panels. You can see that we have all the parameters we need to specify the layout of the PV plant here. We can say what is the panel orientation? Are they portrait or landscape oriented? In our case, it is landscape. We have one panel in a row. So if I zoom in, it is in each row, we have only one PV panel. They are facing south. That's the usual placement in the Northern Hemisphere. And we have a row spacing of 5 meters, tilt angle of 40, almost. Yes, and then a ground clearance of 0.4 meters. We can keep it for our first assessment, but we will also create a new or clone that object. So you can see that we can also easily include a little bit of a different layout. I will close this now, and we will add another PV panel, another PV area, just so we can compare to different ones in the glare assessment with different parameters. I will activate the other layer, and now I will clone this object, or actually first leave the edit mode of that object and clone the object. And now I have a clone of the object here. If I deactivate the previous layer in which we put the PV1, I'm still left with the same layout, but of course I can edit it. I would just say edit mode. And I am free to change the parameters We can increase the amount of PV panels we put on top of each other. So now we'll have 3 in each row on top. And then we can also change the tilt angle, just so we can see what happens if the tilt angle is a little bit lower. And we simply say update selected area, and then we have the layout updated on the map, as you can see here. So now we have, if I activate both layers, 2 different layouts overlapping on the map. We can keep one just for clarity. Nope. We'll exit the edit mode because we are done with the changes. We can close this window, and then we can simply keep one here. And now what else we can do? We can select we have to select the receptors of glare. So as I mentioned, I already created one for building 1, but we'll create 2 more. We simply do it by inserting a shadow/glare receptor. If you're familiar with windPRO and you worked with the shadow module, you definitely are familiar with this parameter. And then, sorry, not parameter, but this object, and we can place it on the map. Here, we say that we don't want to use it for shadow calculation in this particular case, but we do want to use it for the glare calculation. You can reuse the same object for shadow and glare calculations. That is also an option. And then these two, and you can then select them in both calculations. We will say that this receptor is in the building. It is an office with a window facing, and now I have to think, east. So we put that it is facing east. We can also say what is the height above the ground. Just a note here that we do say in the position that we take the height of that receptor already automatically from TIN, so from our elevation model that we have. And so that the offset or the number we put in there will be put on top of that number here. I'll quickly change also the description for clarity. Building 2 and put it on the map. But we can say if the office is maybe on the 2nd floor, we can say more or less 3 meters above the ground that I want to evaluate the glare impact for. And I press OK. And now we have a receptor that is facing the PV plant, and we know all the parameters of it. And then we want to add another one to our project on the other side of the PV plant. We simply say we want to clone the object. And now we will have a clone of this object placed a little bit further away. And we don't really need to go into the properties if we want to change what direction it is facing, because we can simply say we drag it here by this symbol and then we rotate it so that now it is facing the PV plant. I'll still quickly open it and give it a different name so we can distinguish between them in our reports. But so quickly, we are now left with with 3 different receptors, a PV plant. So we have all the necessary objects that we need to perform a glare calculation. How do we do a glare calculation? We simply choose it on the list of the modules that will open the setup window. Here we have different windows available. In our main window, we can select what we want to calculate, actually what we want to include in the calculation. If we want to include the beam spread, or that was also mentioned in regards to the Austrian and German regulations, scattering angle, beam spread, you can include it or not. And then you can also decide if you want to include intensity of glare. We'll include both. We also offer some advanced settings here. You can select a distance limit. We'll not put anything right now, but according to the regulations, you will then be able to say what is the distance limit, and above that limit, we will not consider glare from the PV panels. It is measured from the PV tables separately, so it will not consider PV tables which are further away from the from your receptor than this specified limit here. We have the grid resolution. That is a calculation setting. We work with a sky divided into a grid of points. With this resolution, if we see that there is glare inside a grid cell of this size, we will say the glare is then present in all of the time steps that are inside that grid size. We did perform tests, and this is a setting that allows for a quick calculation as well as very accurate one. So that's our suggestion for the default value. And then you can also choose the time step for calculation to see what accuracy or what time steps we are actually talking about when we talk about glare. You can increase it to a value you want to have. Another setting that was also briefly mentioned is this angle between the reflection and the sun array and the sun ray that you can set to be the value that you need for your glare assessment. We'll keep it at 0, but if you want to do the assessment according to the German rules, then you will put 10 degrees here. And then you can choose which reference year will be shown in the reports. And the next tab is the panel characteristic. And here we can choose what will be the beam spread. We provide default values for different types of coatings for smooth glass, textured glass, anti-reflection coating, and so on. So you can choose it from the drop-down, but you're also welcome to specify a user-defined value here. We'll keep the default, no anti-reflection coating and smooth glass. The bigger the spread angle, the bigger will be the reflection, the longer you will be able to see it. But usually that will also then have influence on the intensity of the reflection. So if you have an anti-reflection coating, maybe you will be able to see that there is a reflection for a longer time, but the intensity of the reflection will be lower. And you can also choose the reflectivity of the PV panel here. We provide built-in characteristics. You can see them in our manual. What are these and how they look? But you can also provide a constant value for the reflectivity if you prefer to specify a user-defined value. We'll again just stick to the default no anti-reflection coating. For the intensity calculations, you're also obliged to put in the irradiance. And this can be done by a constant value used throughout all the time step all year. It's the constant direct normal irradiance value. And you can specify it here, or you can choose a variable model of the DNI where the peak value in each day will reach the specified here, but we will in fact use a model to say that the irradiance in the morning and in the afternoon is lower than the one on the peak. You can see more details also about it in the manual, but basically it will provide more realistic values, whereas this will be definitely a worst case scenario. Yes, once you have all the setup, you can start selecting what should be used in your calculation. And that is, you can say which receptors should be used. We will use all of them. And which solar PV object should be used. And we will use solar PV1. You can see this layer is not active, so I only have one to choose from. And that is the one I will choose in this calculation. So the initial one with higher row distance. Yes, you can also choose a 3D object. We don't have one yet. We will quickly go through it and we'll quickly go through it later. But by pressing OK, we can start the calculation. So we say OK, and we say that we just want to perform the calculation now. And this way, we have the results of the calculation. We have 4 different reports here, and we'll just go through them quickly. We have the main result report, and that's the Here we can see, from the very beginning, what is the setup that we used. We can see the solar areas, the details that are used in the calculation. We can also see the exact placement of the receptors and all the settings that we specified inside the setup of the receptors. And finally, we can see the calculation results. So we can see what is the for each receptor, what is the total time with glare in a year, and what is the maximum daily duration of glare, and also see when is the day when the maximum daily duration occurred. As you can see, we have building 1. If you can remember it from the map, it's the one here in the south that is not getting any glare. That is expected. There will be, if the plant is inclined towards south, will not get any reflections in the building 1. That was just to make sure and see that that this is the case in here. Then we also have building 2. Building 2 being the one on the left side of the plant. And as you can see, we get quite a lot of glare during the year. We have so we exceed by far the 30 hours per year, and we also exceed by far the maximum 30 minutes per day, if that's the case. And we can see that the maximum glare duration occurred in the morning. So when the sun is coming from the east, then we see a reflection in that building 2. For building 3, again, a lot of glare in a year, also exceeded in so quite high values per day. And the maximum glare occurs on 16th of May, and then this time in the afternoon or in the evening. So the sun is coming from the west, and then we can see reflection in building 3 here. Yes. Now to quickly perform the calculation again with the same settings for the other plant, I'll just say I will just rename this calculation to be solar PV1. And I will clone the calculation. This way I can say solar PV2, keeping all the same settings. I'll just change the PV object, and now I will force it to use the PV object 2. So now we have this solar PV object chosen, actually from the second layer, and I will just press OK and do the calculation again. Yes, and now we can see the same information again for the solar PV plant. And now what happened here is that we had this now I will just put it on the map maybe quickly. It will be a little bit easier if I do show you this. Now we have less space between the PV panels. There are more PV panels. So what we can see here in our report is that we have more glare than we initially had in building 2 and building 3. And we can see also the dates with the longest time and so on. But now let's take a closer look at the other results that we can see in the glare module. One other report we offer is the occurrence sun angles. I'll just open it now. And you can see here that we provide the sun angle diagram for the location, and then we can see different possible sun angles throughout the year, the sun altitude and also sun azimuth, and we provide it per receptor. So we have building 1 where we saw that we had no glare, so we also cannot see anything here. And we also have building 2 in which we can see when was glare observed for which sun altitudes. You can also see the times It might be a little bit confusing the first time you look at it. If you're not familiar with this type of graphs, I will just show you that quickly, and we can then jump into a more understandable report we also offer. But again, for building 3, that is here, we can also, let me make it a little bit smaller. We can also see for which sun altitudes and azimuths we see glare at the location. Going back to here, another report is the occurrence time. That is the one that maybe will be a little bit easier to understand. Again, for building 1, nothing shown in here, but for building 2, we can now see the reflection time graph, and we can see for each day when was glare present at our receptor in building 2. And we can see when it starts, what is the date and so on, and how long it will last, and approximately how long it will be per day. And the same for building 3 here. So we can see that it does occur at different times in both of these receptors. Yes. And yes, let me just minimize it. One final report is the map. And in the map, we can see which PV panels are causing the reflections at the receptors. And that is combined map. So at both of the receptors, or actually in all 3, if there was anything at receptor 1. Yes. And remember that you can ask questions in the chat. I know Karina is taking care of finding all the questions, but just so you know, and remember about it.
Yeah. Have we seen the quick view tool?
Yes, I will just go into it right now, but let me also go a little bit back and take you through back to the receptor. What I didn't mention is the field of view, and I wanted to show you that quickly. In the receptor, you're also allowed to specify the field of view, and that is going to say from which directions reflections are actually counting for you. So if you have a window facing east, and you then have a window, so of course only reflections that are coming from this 180 around it will count for your glare assessment. If there was a PV plant placed somewhere else, of course it will not be a problem for you that you see it in from a meaningless direction. Just so you have it here, you can change it to 180. In our case, it didn't really influence the results much. Yes, but now exactly to our quick view tool. Quickly, what else we offer is that if you have a glare receptor, you can right click on the receptor and you can say show glare. What will happen is that you will get an approximate or actually quick calculation with default parameters in here. And you will also be able to see which PV panels are causing the reflection in that receptor. What is also very nice about it is that you can move the reflector different places, the receptor different places, where you will still be able to see when is glare visible, and again see which PV panels are causing the reflection. So you can move it around, have a quick view with this sun angle diagram, and see the PV panels. If I move it maybe very far away, somewhere here, I expect less glare, as you can see, and you can see also the PV panels. Yes. And final part of our presentation will be a 3D object used in the glare calculation. Yes, so I will just jump into it. So you not only can do the calculations with PV panels, but you can also include a 3D object. And a 3D object can be representative of a building, can be representative of a glass facade, and that's what we are going to do today. So we will include a facade of this building actually, which is made of glass, and I can see it from my window. And um, we will simply do it by including a 3D object. So from the list of objects that we have in windPRO, we will select this here, 3D object, and place it on the map. So I will place it here. And first thing we can say, we can change the description. It will be building facade. Okay. Yes. And we can also specify the exact location, but this you can also do on the map and move it around. And you have to select the object file. What we did is that we prepared the glare reflectors that you can use. And that is simply a cube that is 1 by 1 by 1 meter, or a rectangle that is 1 by 1 meter, which you can later scale to this to the sizes that you want to use in the project. I will use the vertical rectangle to simulate the glass facade of the building. And I will say that the coordinate system is correct. And you can say if you want to scale this by a factor or not. And what we have here is you say, okay, width, I wrote down how big should be. It should be 30 meters in width, 12 in height. And we will say these are our sizes of the 3D object. Last but not least, we can change the color symbol, the symbol color. And the symbol color will actually be also reflected in our reports in the maps, or not in the maps, but in the graphs. So you will be able to see the glare from that 3D object marked with this color. We say OK, and we have the 3D object here. We can simply rotate it to fit the location, and we can do the calculation with, let's say, the same settings. I will again clone it, the existing calculation. This will be building. I'll keep the same settings, and we can go to the, we don't want to use the solar PV object anymore, but we do want to use the 3D object. And I will now not include the receptor in building 2, as it is exactly at the same location of the 3D object. So I press OK, and we can get the calculations. Yes, and then again, the same drill as we had for the solar PV is some of the details of the 3D object, and also we can see per receptor how much glare we observed during the year. And quickly, just here, we can also see it on the time diagram for when it can be observed. Final thing, very final thing for today actually, is how you get the intensity calculation out of our glare calculation. Right now, we only offer it as a result to file parameter. So you have to say in your calculation that you're interested in, you have to say result to file, and we can copy it to clipboard. Per receptor, we will choose one that actually had glare, and we have copied it to our clipboard. Then we can put it in Excel, paste it, and for each, that's what we offer in our result to file. We offer all time steps in which we could see glare occurring, together with glare table count, saying from how many different tables did the glare come, and the incidence angle on our reflective surface, the position of the sun, and finally the irradiance. So the reflected irradiance from the PV panel in each of the time steps. That is calculated using the reflectivity model, as well as taking into account the exact incidence angle on the reflective surface. So everything is considered here, and per time step you can see how intense the reflection was. Yes.
Thank you.
Thank you.
Thank you very much, Marta. It was very great. And we have a lot of questions, many questions. We will take some of them, and the one we don't have the time to answer, I suggest we send the answer per writing in email that will be sent to all the subscribers to this webinar. So we have questions about the validation. You have mentioned at the beginning, has the PV plant been validated, the reflection from those ones? And also the other question, it was, I can't remember about the validation, but validation is an important topic. What can you tell us about that?
So we did perform a validation based on another tool, SGH-AT tool. They published a report in which they validated their calculation on an airport in the US. And we did perform the calculation with the same settings and compared to the results they obtained, where we are very close to what they calculate with the settings that we could extract from the validation report they published. That's the PV validation report that we have, and you're welcome to also read more about it in the note that we have on our website. And what we also did is a validation based on our observations, but our observations were made from a glass facade, so next to our office and also one other place in Denmark. So we have these two, and in the validation, and there is one more that I cannot remember now, but there is one more case that is included in the technical note as well, and you're welcome to see it. It's directly available on our website.
Okay, then we have a question about the limits of glare from ESA, which is in candela per square meter. Is that possible to get it with that limit?
That is not directly included, no. We will work, if we see that it is needed, we will work on including that in the next versions. Right now we talk about the reflected irradiance from the PV panel, so it is a different unit. It's watts per square meter.
Okay, and then we also have a question about how to do a calculation and assessment for train or flight path and roads.
Yes, right now at least we don't offer a tool for building these kind of paths, but that's also the approach used in other tools. I believe in Forge Solar, they actually work with points, so you are welcome to define points on the road or points in your flight path, and then perform the calculation as we do here with these point receptors. But if we see the interest, again, we will work on including that.
Yeah, and maybe one final question about obstacle. More than just the elevation, do we take into account any obstacles like buildings on the glare assessment result?
Right now, we don't include obstacles, but that is very high on our priority list to include it, so that you can at least include an obstacle that can be an obstacle in windPRO. So yes, we want to work on that, but in the 3.6 and in the next coming version, it will not be available. So it is the worst case scenario without any obstacles that we are calculating.
All right. Well, we are at the end of this webinar. So well, there were so many other questions, and once again, I will tell you that we are going to answer the question at the end of this webinar and send them per writing. So just to wrap up or to conclude, this webinar will be put on as a video on the YouTube channel of EMD International. And then if you are curious, you will have some more readings like the validation report Marta has mentioned. It's available on help@emd.dk together with manual, quick guides and other stuffs. To answer to your other technical question, you are welcome to send an email to support@emd.dk. And if you want to try the Glare module, which is, by the way, available for any windPRO users until the end of May, but if you want to try windPRO and this Glare module later on, you can ask for a trial to our sales department, which also handles quote and offers, so at sales.emd.dk. Good. Well, we hope you have enjoyed this webinar. It was a pleasure to have you on board. So we would like to thank you and to wish you a very nice day.
Thank you.
Thank
Have
you.
a nice day.